All right, hello once again. This is Jeff Scott of Blackhawk Technical College, and I've been going over the PowerPoint slides for the Starting Out with Java from Control Structures through Objects 6th edition by Tony Gaddis for the 152-143 Intro to Java Programming class for the Spring 2016 semester at Blackhawk Technical College. I'm now up to Chapter 6. I'm going to go through the first 10, maybe 11, but we'll see, probably the first 10 chapters. Okay, so Chapter 6 is called a first look at classes. And what we're going to do, which we haven't really done before, is we're going to look at objects and classes in much more depth and breadth of coverage, including writing a simple class that's going to figure out basically the area of a rectangle, the height times the width, and we'll do that step by step. We'll talk about instance fields and methods, what a constructor is, how to pass an entire object as an argument, a little bit about what overloading means, and I might even mention overriding because they sound similar, but they're totally different things, the scope of instance fields, more on packages and import statements. All right? So, when you create an object is an instance of a class. An object, as mentioned there, exists in memory, and ideally, an object should perform a specific task. Objects can store data that are known as attributes, sometimes known as fields. Objects can perform operations, sometimes known as behaviors, sometimes known as methods. We've already used the scanner object, the random object, the print writer object, etc., so we've looked at some of those. Notice as it says here, when a program needs the services of a particular type of object, it creates that object in memory and then calls the methods that the object has to do whatever work is necessary to be done. So a class is kind of like a blueprint. The class specifies what data and what methods any object of that particular class are going to contain. So much like a blueprint for a house is used by a builder to figure out, where to put things, how big to make things, etc. In much the same way, a class is a blueprint from which you make objects. In fact, the act of making an object from a class is known as instancing or instantiation. So here's an example looking at something we've already used. When you say scanner keyboard equals new scanner system.in, scanner is the name, all right? Basically, it says the object's memory address is assigned to the keyboard variable. So that's the variable, all right? And it's really a member of that class. So really, keyboard is the object of class scanner. Now that's not exactly what the author says here, but pretty much that's what's happening. Scanner is the class. Keyboard is the name of the object of class scanner, okay? And in order to do its thing, it needs to have a parameter passed in this case, system.in. On the other hand, when we did random, notice that random doesn't need anything passed in. All right, again, rand is the object of type random. Print writer, much the same thing, okay? Do something here if you don't mind. So, as mentioned here, the Java API provides many classes. That's really what the API is. It's a list of classes that have a list of methods and data, and it's stuff that's been pre-written for you so that you can use it. These are 3 examples of API classes that we've used thus far in the semester. So what we're going to do now is we're going to build a class, as they say here, step by step. The classes will be of type rectangle, all right, and it'll have a length field, and it'll have a width field, okay? It's also going to have several methods. We'll be able to set the length and set the width, get the length and get the width, and get the area. Now you'll notice that about half of these methods start with the word set, and about half, I guess a little more, start with the word get. When you've got methods that start with the word set, like these two right here, these are known as mutator methods because they change things. When you've got methods that start with get, those are called accessor methods because they don't change. They're also called sometimes query methods. Think about it this way. All right, when I was first born, all right, that was the only time technically that my parents actually set my first name. They set my middle name, and my last name, of course, would be the name of my parents. All right. Then when the nurse came in and said, well, we want to put a name on the tag that the baby is in, what name should we use? And they said, Jeffrey Paul Scott. That was get first name, get middle name, get last name. All right. When you are creating your accessors and your mutators, there's a way to very quickly do it inside of Eclipse, and we'll talk about that in a little bit. All right. They also start to show in here, they talk about UML, which is the Unified Modeling Language. And I'll go over it, but I'm not going to spend a lot of time on it. Years ago, we used to have a couple classes in systems analysis and design where we would learn how to create a system basically from scratch. That stuff is still very important. The problem is, as you know, every time you add a class, you've got to remove a class. So as we went in and started adding more complex programming classes, the systems analysis and the system design classes were two of the ones that left. All right. But when you have UML, you write basically a square or a rectangle and you separate it into thirds. The name of the class goes in the upper third. The fields or the attributes for the class go in the middle section, and the methods go in the bottom section. And here's an example. So we've got a class that's named rectangle. It has two pieces of information, a length and a width. Then there's a set length, a set width, a get length, a get width, and a get area. All right? So as we start to write this, private class rectangle. All right? In fact, let's do this. I should say public class rectangle. All right? So what I'll do here, and this is probably going to take a lot more time than I want it to, but it'll be fine. Let me open up the virtual desktop. Might still have some stuff open from yesterday. Yeah, I do. All right, so I've got this goofy example that I was working on. I'm just going to close that. And I'm going to start to create a new project. So I'm going to say File, New, Java Project. I'm literally just going to call this one Rectangle. All right, and click Finish. Right mouse click on it, go to New, put a package in there. The package is always done with reverse domain notation, so I'm going to do edu.blackhawk.jscott. And packages also always hold classes, so I'm going to put a class in here that I'm going to call Rectangle. All right, so there's the beginning of my class Rectangle. I'm going to remove that. I think we can copy that in. So that's what we have so far. All right, Rectangle, which must be the same as the name of the class because it's the name of the public class. It's inside of this package, and we'll talk about packages at a later time. Right now, it has two fields in it, a double call length and a double called width. You may notice that unlike what we've done in earlier lectures, I am not, repeat, I'm not initializing those variables right here. They'll be initialized a little bit later, and you'll see this as we go on. All right, so that's the beginning. So far we've got a public class named rectangle with two private fields in it. Length, which is a double, width, which is a double. All right. Remember that public and private, those are known as access specifiers. As it says, when you use public, the member can be accessed by code inside of the class or outside of the class. When you say private, it can only be accessed, in this case, our private data. This can only be accessed by methods within this class. So I told you this in an earlier lecture. I said, although this is a gross simplification, that what you have in object-oriented programming is you have public methods that manipulate private data. All right, so here's all the stuff in action, so to speak. Public for our access specifier, void for our return type, meaning it won't return anything, set length for the name of the method, and it requires a double that we call len for length. So here's what we have. So again, I'm just going to keep copying the stuff from here. So this is what we have so far. I do want you to understand something. Notice here that it's called length, and here it's called len. If we wanted, we could call this length also. But if we did that, and if we did length equal length, the system would be confused. So we have to use here, we'd have to say this dot length equal length. All right? That's a fairly complex topic, and I just wanted to mention that to you just so you saw it. All right? But what this is doing is it says later we're going to create an instance of a rectangle, and we're going to pass in some length to it. And it says take whatever length we passed into it and copy that into this variable right here. And if you said, well, are we going to have another one for height? Yes, in just a couple minutes. So now if we say rectangle box equal new rectangle, all right, right now we'd be passing nothing into it. So really length and width would be set to 0. We probably don't want that, but if we call set length, now we can change the length to 10. We can't do anything with the width yet because we haven't created a set width method. So as it says, this is the state of the box after set length executes. So if you can imagine, that's your rectangle. Initially, it had a length of 0 and a width of 0. And you look at that and you go, wait a minute, Jeff. Wait a minute, Jeff. No, that's not right. Because if you look at this, we didn't give it a value. All right? But since we created the variables outside of any method, these are automatically initialized to 0 for us. Remember, they're not local variables. They're actually what are called instance variables. We're going to get into that more length and depth and breadth of coverage as we go on as well. All right, so as soon as we call set length, so notice we're creating a brand new rectangle we're calling box. We're not passing anything into it. So that means length and width have their initial values of 0 each. Then we're saying set the length of that box to 10. So now length is 10. All right. Then we can go in and call another thing in here that's called get length. So we can come in here now and add get length. All right. The order in which we do this is pretty much up to us. And what I mean by that, and I'm not trying to confuse you here, notice we've got a set followed by a get, but they're both length. Sometimes people like to do that, and sometimes they like to put all their setters together and then put in their getters. So I'm going to copy all of this. This isn't the greatest way to do this, but it's a quick way of doing it. I'm going to copy all of it, and I'm going to paste it in. You're like, why did you do that? You already had that there. I understand that. But I'm going to change the second one from length to to width. You'll notice as I'm changing everything from length to width, all those error messages that are in there, they're all going away. Oops. So again, this will go to get width rather than get length. You can see how it goes away right away as soon as I put that in there. Then any errors that we have are going away. All right. And this is the kind of thing, just so you know it, that we're going to be doing literally from now on in this class. This is the way that you create a class, and we're just creating it from scratch basically. So far we've got a length and we've got a width. We can now set our length and get our length, our mutator and our accessor. Notice for a mutator, the name of our instance variable, length, appears on the left-hand side of an equal sign. For an accessor, all we do is return it. Since we are not returning anything in here, our return type is void, but we pass a value in. For our get, we're not passing anything in, but we're returning something, so we must put a type in there that's not void. And the same kind of thing with width. All right, so far, we've started to create a rectangle class. We've got a set length, a get length, a set width, and a get width. All right, now we're also going to have a get area in here. So let's put this in. And this one, for lack of better verbiage, is a little bit different. It looks very similar to the other ones, but it is a little bit different. And what I mean by that is normally when you've got a get, you don't do any calculation. But if you notice in here, we're returning length times width. And what we're trying to do is we're trying to make sure that every time we call get area, that we have the quote freshest data we can. All right, so we're actually doing a calculation in there to avoid what's known as having stale data. It'll be talked about in here, and we'll talk about it more in class as well. Again, the fields in here are private. The methods are public. Methods that retrieve data or return something are called get or accessor methods. Methods that modify or change data start with set and are known as mutators. Each field that we want to have other class look at, anything to be able to look at needs an accessor. Anything we wish to be able to change needs a mutator. So this is what we've created. Again, as it says, sometimes these are known as getters and setters as well. All right. Notice an object hides its internal private field. So the only way that you can manipulate this private data is through these public methods, and that's exactly what they're talking about here. As mentioned, data hiding is important because you're then able to use the class and not have to really realize how it works. It helps to enforce the integrity of the object's internal data. This is the stale data that I mentioned before. We're not creating a variable called area. We're just returning the length times the width. And as mentioned at the bottom here, to avoid stale data, it's best to calculate the value of that data within the method rather than store it within a variable. So that's what we've done. Now, anytime you change the length or the width variables, all right, the area will be updated immediately as soon as you call get area, so you won't have that stale data. So this is how this is starting to look now in the UML. This isn't complete, but it's showing width, and there's a minus sign before it, meaning that it's private, and it's got a colon and double to show its data type. The set width has got a plus in front of it, meaning that it's public, and it also has W colon double in it, and that means that it's going to require a parameter of type double that we'll refer to now as W, and it returns nothing. That's the colon void at the end. All right, you see a similar thing for set width. So there is software that will take a UML diagram that you've created and it will create Java code from it. There's other software that will take your Java code and will write a UML diagram from it. All right, but most of the time people end up doing this. So it says the name of the class is rectangle. There are two pieces of private data, width and height. They're both doubled, so you see those there. There's rectangle, rectangle. You've got 1, 2, 3, 4, 5 methods, 2 set methods, each requiring a double, each returning nothing. Those are these right here. 3 get methods, each having no parameters passed in, each returning a double. Double, double, double. All right? So we take this and we convert it from just having nothing in it to actual values. All right? Okay. As it says, the layout of a source code file can vary based on what the place you're working for wants, what I would want, how way you want to set it up. So the way that Gaddis does it in his book is he does his fields, his private data first, and his methods second. He groups together his accessors and mutators, and like I said, sometimes you want to do that, sometimes you don't. All right? And he says there are tools to help in formatting the layout. We'll talk about those. Fields and methods that are declared in this way are called instance fields and instance methods. So each object that we create will have its own, so each rectangle we create will have its own height, width, set width, get width, get area. And that's exactly what they're saying. These instance methods are not declared with the keyword static. All right. The other thing you may or may not have noticed is in here, so far, there also is not a main. All right, we'll get into that in just a bit. Instance fields, it says, and instance methods require an object to be created in order to be used. So here's 3 examples. We could create, let's say we were trying to do the dimensions for a room in a house. We could say rectangle kitchen equals new rectangle bedroom equals new rectangle, and rectangle den equal new rectangle. All right, so we'd have this kind of stuff. Then we could call set length, set width on each one of them and put these values in there. All right, one thing we have not talked about yet is there is a special method that you have at the top of a class typically, and it's called a constructor. A constructor is a special method that's automatically called when the object is created. Constructors typically do initialization types of tasks, and they can do other things, but usually that's what they do at the beginning of the program. All right? Constructors have the same name as a class. They cannot have a return type, not even the word void. They may not return values, and they're typically, in fact, I've always seen them as being public. So here's an example of a constructor. So I'm going to grab this code that we've got right here, and I'm going to copy that. But I like to put my constructors at the top of my program right after I've created my class variable. So I'm going to put that right here. All right, doesn't look like much. Really doesn't look like it's doing much. But what it says is when we create a rectangle now, it will be expected that we'll pass in 2 doubles to it. The first double we pass in will represent the length of the rectangle. The second double that we pass in will represent the width of the rectangle. All right, so we're getting an entire class that we're making here. As you see, our UML is also increasing here because now we have the constructor. All right. It says reference variables can be declared without being initialized. So if we say here, rectangle box, it's declaring a variable of type rectangle, but since we're not initializing it, it doesn't really create the rectangle object yet. It's only later when we say something like box equal new rectangle 7.0 14.0 that now we've got a rectangle object. It'll have a height of 7 and a width of 14. All right. When an object is created, its constructor is always called. If you don't write a constructor yourself, the system will write one for you, and that's known as a default constructor. Notice it sets all of the object's numeric fields to 0, all of its Boolean fields to false, and any special object variables it has to null. So just so you know this, had we not come in here and written this, so I'm going to take it out for just a second. All right, the system would have come in and written this, public rectangle, and it would have given us a constructor with nothing in it. That's a default constructor right there. All right, so if you don't create a constructor, one gets created for you by the system. All right, but we want our own constructor, so that's why we've got this one here. All right, the author mentions right here the default constructor is a constructor with no parameters that really doesn't do anything. The only time that Java provides a default constructor is when you don't write one for yourself. If a constructor is already written, Java does not provide a default one for you. If you have a constructor that accepts no arguments, that's called a No-Arg constructor. So if we wanted to set this up so that you could have that you could create a rectangle class but not have to pass anything into it, we could write another constructor that did that. So I'm going to put this in here. You'll notice I don't get any error messages because there isn't an error. I'm going to grab all of this documentation code right here, all of that, copy it, and paste it in there. Now, in English, what this says is that I have two different ways now I can create a rectangle. I can pass in nothing, and if I pass in nothing, the length will be equal to 1 and the width will be equal to 1. Or I can pass in values, and whatever value I pass in first becomes the length, whatever value I pass in second becomes the width. So I can do it either way. You can see the program's getting bigger, plus we put a lot of documentation in here. All right. They talk about the fact that the string has a constructor, so we're used to writing things that look, for lack of better words, we're used to writing strings that look more like this. String name equals Michael Long, like that. And that's totally fine to write that. But even though that's a shortcut for us, when you write that, the system actually does this. Since you're creating a new object, it has to call the new function. It says it's of type string, so that type and that type must be the same. And that's the value that gets passed into it. But the same thing happens as what happens with what I just showed you. And that's what they're showing here. All right, when you pass an object as an argument, you're passing the address. So any change that you make to it is a permanent change. All right. Now, the next thing to discuss here, because we're almost to the end of the chapter, talks about overloading methods. And you already saw it, even if you don't realize it. Notice we have here public rectangle, paren, paren, and public rectangle, double len, double W. All right, we have the same, these are both constructors. We've got the same constructor, it's got the same type or access specifier, and it's got the same name. So the public rectangle there and the public rectangle here are identical. What's different between the two, what's different between them are the fact that this is our No-Arg, so there's no arguments, and this has arguments. So when you have a method that has the same name, but it has different things inside of the parentheses, That's what's referred to as an overloaded method, and you're going to see much more of this as we go on in here. They say method overloading is important because sometimes you need several ways to perform the same operation. Here's an example. We've got a method add, and in the first case, we're passing in two integers and adding them together. In the second case, we're passing in two strings and concatenating them together. But notice they both are called public add, even though the return types are different. The return types can be the same, but when you overload a method, what appears in the parentheses, your argument list, they must be different. As it says there, the method signature consists of the method name and the data types of the parameters. The return type is not a part of the signature. So this is the signature right here, the name and what's in here. And you can see that although the names are the same, the parameters inside are different. The process of matching a method call with the correct number and type of parameters is known as binding. And what you'll learn as we go on in here is some things in programming languages are what are called early binded, which means when you compile the program, the system has to know everything about it. Sometimes things are called late binded, which means that the system can wait and not figure it out until the program is actually running. When we get into arrays and stuff, that'll become more important. All right. It says if we were to add the No-Arg constructor we wrote previously, it says what would happen if we executed the following calls. Well, this first one would have a length of 1 and a width of 1. The second one would have a length of 5 and a width of 10. All right. So the first one would use the No-Arg constructor. The second one would use our constructor where we pass in two doubles. All right. There's about 3 or 4 more slides, but before we do that, what I'm going to show you is I'm going to grab these 2 lines of code here and show you how we typically would write this program. So we've already got our rectangle.java. That's cool. Not a problem with that. Okay, I'm going to save this. Now I'm going to come in and I'm going to do a file, new, and I'm going to say, not project, but I want to put in a new, in here, I want to put in a new class. So new class. And I'm going to call this one rectangle demo. And I am going to put a main in here. All right. So there it is. And what I'm going to do is take those 2 lines of code that I just put in and I don't know what that is, but notice I don't get any error messages. I get a couple warnings because I'm not using box 1 and box 2 yet. But I'm going to come in here and I'm going to do this. Box 1, here, let's say, system.out.println. The values of box 1 are, all right, and we'll put in here, this is going to look a little funky for a second, so just trust me. Height, box 1 dot get height, I guess that's length. It's length and width, so not height, but length. All right. And width, all right. So hopefully I didn't make any mistakes in there. It looks like it's okay. So I'm going to do that. And then I'm going to do the same thing, but I'm going to do instead, this time it'll be for box 2. And I'll put a couple of blank lines between them. All right, now I'm going to come through here and I'm going to run this, but it's not going to run. Yeah, let's run this. The values of box 1, length 0, width 0, so it called our No-Arg constructor. The values of box 2, length 5, right there, and width 10, right there. So what we did was we have a file over here that's got all of our rectangle information in it. And then to demo it, we need another file. So we actually have two classes. One class that represents our rectangle, another class that allows us to demo our rectangle. All right, just so you can see how that works. The chapter ends here with the last 4 or 5 slides. The author starts to go through another example of a bank account. And they say this particular bank account has got what? It's called bank account. It has a private double variable called balance. Notice that it has 3 different constructors. One that's a No-Arg constructor, one that has a double passed in, one that has a string passed in. It's got 2 different deposits methods, so they're both overloaded. One has a double, one has a string. 2 different withdrawal methods. One has a double, one has a string. You notice that all these don't return anything. All right. And a set balance with a double, a set balance with a string, and a get balance that returns a double. Okay. We'll talk about that in more depth and breadth of coverage when we go over the other part of the lecture, not the PowerPoints here. All right. Variables declared as instance fields in a class can be accessed by any method without having to be passed. All right. It says there, if an instance field is declared public, it can be accessed. There literally is almost never a reason to take an instance field and make it public. Okay. All right. They talk about shadowing here, and I just want to mention this just so you see it as we're finishing up here. That if I come through here and I go into my rectangle here, I've got length and I've got width here. All right. If I were to come in here and inside of, let's say, don't ask me why I do this, but if I came through here and said int length, all right, I'll make it a double, but double length equals 224. All right, that'd be a dumb thing to do. But what they're saying is, since I've got a field called length and I've got another one outside of here that's called length, this is the one that's known everywhere throughout the program. But if I come in here and create another one in here, this one shadows the other one. So I don't even know that the other one exists. What does that mean? Well, notice that we've got in here our call to get length and get width. So let's go back to this one. We'll save it. Then we'll go back to our demo and we'll save that and run it. Notice it says the length is 224 each time. That would be wrong. The point of the matter is that it is possible to come in, and even if you've got an instance variable that's been declared at the top of your program, you can declare another variable of the same name in one of the methods. Even though you can do it, you really should not do it. It's bad practice. So really, when I run this, that's the way that it should look. All right. All right, as far as packages and import statements, as it says, the classes in the Java application program interface are organized into packages. When you decide you want to bring those packages into your program so that you can use the particular methods that are associated with them, you do what's called import that stuff. All right. If I did an import java.util.scanner, that would bring in the scanner package. If I said import java.util.star, that would bring everything directly underneath the utility package, including scanner. So this is called a wildcard. Here's some of the standard Java packages. Ones that you'll deal with in this class, or in this class and the advanced class: java.applet, java.awt, java.io, java.lang. You never have to provide this one. It's automatically provided for you by the system. Java.sql, java.text, java.util, and java.swing. You learn much more about those as we go on. And the very last thing that's mentioned in the chapter is the author says that when you're going through requirements and you're trying to find classes, all right, you're given some specs. You'll typically go and identify all the nouns that are in your requirements or your specification. That's your problem domain. Each one of those nouns is potentially a class, but you'll go through them and realize some of them are not classes. They might be objects or they might be something else. Then you identify all of the responsibilities. That's typically the verbs. Those are things that can potentially become your methods. All right? As it says, things a class is responsible for knowing, for doing, and then you refine it as necessary. And that's it for this chapter.